For as long as we've looked to the stars, we've wondered, how does it all end? The story we've been told is one of cosmic grandeur, but it finishes with a cold, silent whimper. Trillions of years from now, the last star will flicker out. Galaxies will dissolve into a thin, cold soup of stray particles. The universe will become a vast, dark, and empty graveyard, expanding forever into an eternity of darkness. Welcome to David Planetborough. Today, we explore the heat death of the universe, the final, lonely chapter of existence as we know it. But what if that's not the end of the story? What if the universe has a secret reset button? A speculative but fascinating theory proposes that when our universe fades to black, it could trigger a mind-bending transformation, a reboot of reality itself. To understand this new idea, we first have to appreciate the story it's trying to replace. The standard model of cosmology is a linear one. It begins with the Big Bang, roughly 13.8 billion years ago. From an extremely hot, dense state, space and time exploded into being. In the seconds, years, and millennia that followed, the universe expanded and cooled. Gravity pulled matter together to form the first stars, the first galaxies, and eventually planets like our own. This expansion continues today. In fact, it's accelerating, driven by a mysterious force we call dark energy. And this is where the bleak ending comes from. If the universe keeps expanding, cooling, and accelerating, everything will eventually be pulled so far apart that the cosmos becomes a featureless void. All usable energy will be spent. Some theories even speculate that all matter itself could eventually decay, though it's important to know that things like proton decay have never actually been observed. It's a one-way ticket to oblivion. This vision of a final, irreversible end has dominated cosmology for decades. It's a complete story from beginning to end. But for some, it just doesn't feel right. This is where Nobel Prize-winning physicist Roger Penrose comes in, with his theory, conformal cyclic cosmology, or CCC. Penrose, a giant of modern physics and a longtime collaborator of Stephen Hawking, argues that the Big Bang wasn't a unique beginning at all, but simply the end of a previous cosmic eon. Now, it's important to say up front, CCC is highly speculative, and it is not widely accepted in the scientific community. But the idea is just too interesting to ignore. Penrose's theory doesn't rely on the universe collapsing back on itself in a big crunch, like some other cyclic models. Instead, he proposes something far stranger. He suggests the universe expands forever, just as the standard model predicts. But in its final state, something incredible happens. The very concepts of time and distance could lose all meaning, allowing the infinitely large, cold, and empty end of one universe to become mathematically identical to the infinitely small, hot, and dense beginning of the next. So, how can an infinitely large, dead universe become a new Big Bang? The answer lies in a strange property of physics, when everything has lost its mass. According to conformal cyclic cosmology, in the far, far future, all matter as we know it will have disintegrated. Even the supermassive black holes at the centers of galaxies will have evaporated through Hawking radiation. A key requirement for the theory to work is that all particles must eventually lose their mass, something for which we currently have no evidence. But it's did, the universe would be filled with nothing but massless particles, like photons, particles of light. And here's the crucial part. For a massless particle, our concepts of time and distance don't really apply in the same way. Without mass, there are no clocks, no rulers. The universe, though technically enormous, loses its sense of scale. Penrose realized that through a mathematical lens called conformal geometry, you can rescale this infinitely large, empty, cold universe. You can squash its infinite future down and remap it. And when you do, it looks exactly like the hot, dense, infinitely small state of the Big Bang. The death of one eon seamlessly becomes the birth of the next. It's a transformation where scale itself dissolves and is reborn. This all sounds like a cool thought experiment, but Penrose insists it's testable. He argues that if a previous eon existed, it might have left faint echoes in our own universe, imprinted on the oldest light we can see, the cosmic microwave background. His theory predicts specific anomalies in the CMB, which he calls Hawking points. In the final moments of a previous eon, evaporating supermassive black holes would release a final burst of energy. Penrose argues this energy could punch through the transition, appearing in our sky as distinct circular hotspots. And here's where it gets controversial. Penrose and his collaborators claimed to have found these points, along with other features like concentric circles, in data from space telescopes, suggesting they were remnants of a past universe. However, this is where the scientific community largely disagrees. Multiple independent analyses have re-examined the data and concluded that these so-called anomalies are not statistically significant. Critics argue they're likely just random fluctuations or statistical flukes that you'd expect to find in the standard model of the cosmos, not ghosts from a universe before our own. The debate is a perfect example of the scientific process in action. But for now, there is no accepted observational evidence for CCC. But let's just imagine for a second that Penrose is right. The implications would be staggering. It would mean our Big Bang wasn't a singular creation out of nothing, but just another tick of a cosmic clock. In this picture, the universe has no true beginning and no end, just an eternal cycle of death and rebirth. This also provides a wild new perspective on the Fermi paradox, the question of where is everybody? Penrose has speculated that an advanced civilization in a previous eon could have found a way to send information across the boundary into the next universe. Could there be messages hidden in the faint glow of the Big Bang, not just from dead black holes, but from a civilization that existed before our time? This is, of course, pure conjecture, but it's a mind-bending thought. For decades, we've imagined the universe would end in a cold, desolate darkness. Conformal cyclic cosmology offers a different, almost poetic alternative. It suggests that from the ashes of a dead cosmos, a new one can be born, caught in an eternal loop of renewal. While the theory remains on the fringes of cosmology and is heavily debated, it forces us to confront our most basic assumptions about reality, time, and our place in the cosmos. It challenges us to see the Big Bang not as the starting line, but as a baton pass in a cosmic relay race that stretches across eternity. It tells us that the end isn't an ending at all, it's just a reset. If the universe can reset, what does that say about the nature of time and our place within it? Subscribe and let me know your thoughts in the comments below.